Hello and welcome to our team demonstration video. We are Andrea Irwin, Mark Zalick, and Sean Mack, and today we would like to tell you about our experiences working on a malware analysis project as part of Oregon State University's Computer Science Capstone course. We have a number of items we'd like to get through today, beginning with an introduction to our project and what it entailed, as well as why we found it so compelling. Second, we would like to give you some highlights over the tools and methodologies that we used to conduct our malware analysis before going into a demo of our analysis in action. Third, we would like to share our individual journeys over the course of this project, including our greatest challenges and our top lessons learned. And then finally, we would like to conclude by sharing some thoughts over where we see this project going in the future. So to begin with, our biggest motivations for why we want to work on this project all stem from the fact that we intend to go into careers in cybersecurity. We wanted to create a guide that would allow similar people who have a passion for cybersecurity but have never conducted malware analysis to be able to learn how to perform malware analysis on their own at home in a safe and secure manner using a home lab. And so we intend to create a guide for these people that they can use to start learning how to perform malware analysis. Second, we wanted to develop our own cybersecurity skills, especially in areas that none of us had done before, including static, dynamic, and advanced analysis of malware. And then third, we of course each have a shared interest in analyzing malware and combating cybersecurity threats. So our project was broken up into 3 phases. The first was to establish a safe and secure laboratory environment in which we could perform malware analysis without running the risk of infecting our host machines. And we did this using a series of connected virtual machines. On those virtual machines, we installed our malware, as well as the tools that we would use to perform static, dynamic, and advanced malware analysis. And then once we had achieved sufficient results and sufficient understanding of what the malware did, then we compiled those results into our final report that we intend to publish to the public. So our process started by setting up our lab environment, and we did this with virtual machines with the tools that we would be using. Once we had that established, we downloaded our malware to our primary virtual machine, and then for the selected malware that we wanted to work on, we performed static analysis in order to extract information from the malware without having to run it. And this allowed us to form hypotheses about what the malware might do before moving into dynamic analysis, in which we, in a controlled and safe manner, execute the malware and compare the state of the system before and after executing the malware. Once we had done that, we performed advanced analysis in order to gain a greater understanding into what the malware does, as well as to use a debugger to help corroborate our findings. And then, once we had decided we had a sufficient understanding of the malware, we took those results and put them into our final report. So what did our lab setup look like? Well, we used VMware to host 2 virtual machines. The first running Windows XP, because that is the operating system that our selected malware targets. And the second virtual machine running Ubuntu in order to run tools that we would use to respond to network requests that the malware might make, say if it wanted to contact its command and control server. Then we took malware samples that we found from our primary source for this project, which was the book Practical Malware Analysis by Michael Sikorsky and Andrew Honig, and then we performed our analysis on those selected malware samples. So we performed that analysis using a series of tools that each specialized in different parts of static, dynamic, and advanced analysis. For instance, Dependency Walker allowed us to be able to see which Windows operating system calls an executable might import and potentially call when it is run. And we could make guesses as to what the malware might do. For instance, if a malware imported the function URL download to file, then we have a good idea that it might be going out to some website and trying to download data, which it would save to a file on the infected machine. Tools like INetSim, Apate DNS, and Wireshark allowed us to direct and sniff network traffic that the malware might make so that we could see how it was trying to interact with its command and control server. And then a tool like IDA-Free allowed us to be able to disassemble and reverse engineer the actual code of the malware itself so that we could gain that greater understanding of what the malware was trying to do. So now I would like to go into a demonstration of our analysis in action. Okay, for our demo, I would like to share our laboratory setup as well as some highlights from the analysis of one of our samples. So you can see VMware running with two virtual machines, one with Windows XP with our installed malware and some of the tools that we use for analysis. And in the second, we're running Ubuntu with a couple instances of Netcat listening to specific ports. And we will know that that we have successfully understood what this malware is doing when we make it reach out to and request information from these two Netcat instances, and we see these Netcat instances respond. All right, so back in our Windows XP VM, we have this malware here, lab91. And if we just try to naively run the file, what happens is a command shell briefly pops up, and then the malware file itself has disappeared. So this is slightly to be expected, because if we look at Dependency Walker, we can see that this malware imports this function shell execute, suggesting that it is capable of executing a shell command. However, using the dynamic tool process monitor, what we've learned is that what's happened is the command that has been run simply deletes all traces of this malware from the system. So the malware has not successfully installed itself. Now, using advanced analysis, we were able to learn that in order to successfully install the malware, you actually have to run it with a particular password and combination of flags. So we know that in order to install this malware, we have to run it with the flag -in and the password ABCD. When that happens, using a tool such as Redshot, we see some changes to the registry key Microsoft XP configuration. And if we decode the information here from hex to ASCII, we see some strings. And if we run the flag -cc, we can see those same exact strings pop up, suggesting that this is configuration information from the malware. So this suggests that it has been successfully installed, and now if we try and run this malware, what happens is the file doesn't delete itself, and if we go over to our Ubuntu image, we can see that a request has been made to one of these Netcat instances, and it is responded with a file that tells the malware to reach out to the other port that we're listening on, and we can see that that Netcat has also been hit. So we can see now that the malware has to be successfully installed with a password and flag, and that once it's been installed, it is actually running as a service, and it is periodically reaching out to its command and control server for specially crafted messages that tell it to perform certain commands. Okay, now I will hand it over to Andrea to talk about our individual contributions.
Our original plan was to each pick a malware strain to analyze, but we realized that it would be more fruitful to work on the same strains to compare and contrast results and create a more well-rounded and in-depth analysis. The challenges I came up against included the Ubuntu virtual machine setup and the tools involved with advanced dynamic analysis. I have less experience working in Linux environments, and most of my work with malware analysis has been in basic static and basic dynamic tools. My teammates had more experience in these areas, and I was able to learn from them and avoid falling behind any blockers. In the course of this project, I have become more comfortable with the process of setting up an isolated virtual network with all of the tools in both a Windows and Linux environment. I also now have a better understanding of what to look for when analyzing potential malware, including in tools such as Process Monitor, Redshot, and
Thank you, Andrea. So as far as my individual contributions to the project, The biggest difference between our original plan and what I ended up working on is that we had decided to switch from working on individual different malware samples to working in parallel on the same malware. And we did this so that we could bounce ideas off of each other and to gain a greater understanding of what the malware was doing while simultaneously teaching each other how to perform malware analysis. My biggest challenge over the course of this project was in setting up the network between my virtual machines, because after my initial attempt, what ended up happening was that my host machine would consistently drop its network connection regardless of whether or not I had the VMs running. And through trial and error, I was able to figure out that by switching the network that my VMs were using as their host only bridge, I could resolve my host network connectivity problems. And then my greatest takeaways from this project have been, one, in feeling more comfortable in setting up a secure environment in which to perform malware analysis without running the risk of infecting my host machine with malware. Two, I feel more comfortable in understanding how Windows operating systems calls work. And even if I didn't have a chance to research a particular system call over the course of this project, I now feel more comfortable in knowing where to go to look for more information about that particular system call. And then finally, my favorite part of this whole project has been reverse engineering using IDA. And in particular, while I had some previous experience with reverse engineering, I have not previously worked on reverse engineering Windows targeted executables, nor have I had a chance to use IDA. And I've really enjoyed the opportunity to be able to reverse engineer Windows malware with IDA free over the course of this project. All right, now I'll pass it over to Sean to talk about his individual contributions.
So, as was mentioned by my colleagues, we discovered that our endeavors of studying different malware strains were a bit of a stretch, so we decided instead to study the same malware strains. The largest challenge that I face stems from the fact that I'm most well versed in the Python programming language, which is an interpreted language. I haven't coded extensively in compiled languages such as C++, so my understanding of how executable binaries are coded and compiled and how dynamically linked libraries are utilized was limiting at first. However, after learning from my colleagues and reading more about the topic online, I was able to work through this challenge. Throughout the process, I learned a great deal of information. One of the most important things I learned with this project is how to set up a safe and secure environment for performing malware analysis. Now, I currently work at OSU's Security Operations Center, so this project has also allowed me to better understand potential signs of compromise to look for when responding to incidents. Like I mentioned, my understanding of how executable files are structured was very limited at the start of the project, so I learned a lot about compiled binaries. Lastly, I have become more familiar with the inner workings of the Windows operating system, especially in regards to how the registry works and how Windows utilizes dynamically linked libraries. I've greatly enjoyed learning about the science and art of malware analysis with my colleagues.
All right, so where does that leave us going forward? Well, we each believe that this project has given us a solid foundation for knowing how to analyze Windows based malware in a safe and secure environment. And while we don't believe there is a commercial application for our findings for this particular malware because it is based on academic malware, we do believe that we can publish our information to our professional network in order to acknowledge what we have learned and in order to seek feedback from our peers and from experts. And in addition, we believe that we can continue to build our skills in malware analysis by seeking out more advanced topics like malware, which uses obfuscation to hide what it does, or we can target real world modern malware. In conclusion, we believe that this project has given us a solid foundation for learning how to perform malware analysis that we can take going into our future careers. Thank you very much. We hope that you've enjoyed this as much as we have. Have a great day.